Hello students, in this question they had mentioned that a body weighs 450 gram force in air and 310 gram force when completely immersed in water. So suppose you have suspended an object with a spring balance, and if you take its reading in air, then its reading is 450 gram force. It means the weight acting or the weight of the body in air is 450 gram force. And when you have submerged or immerse that body, whenever you have dipped this body completely inside water, then its weight becomes 310 gram force. So this 300 gram force can be considered as its apparent weight, and 450 gram force, which is its weight in air, is considered as its true weight. Okay. So why this weight has been decreased? So because whenever you submerge a particular object in any liquid or a gaseous substance like water, air, etc. So in air, actually, its density is less, so upthrust is less. So we ignore the upthrust in air. But apart from air, in any other gases which is having high density or any liquid, most probably we can observe the upthrust in liquids easily. So whenever you submerge an object in liquid, so this liquid exerts some upward force, upthrust on the body. So due to this upthrust, the apparent weight of the body decreases. So here we need to find the volume of the body, the loss in weight of the body, the upthrust of the body. And we need to take the assumption made in first part. So here, the mass of the body, we can find out that its weight in air is 450 gram force. It means the weight is equal to the gravity acting on an object of mass 450 gram. So here we can say mass of the body is 450 gram. But still, we don't have the density of the body. So directly we cannot find its volume. Okay, by direct method, that is, we know the formula that density is equal to mass by volume. So volume is equal to mass by density. But here, since density of that body is not given, so we cannot use that direct formula to calculate volume. Then how will we solve this? So we will solve this by finding the upthrust first, and okay, then comparing it. Okay, we can find out the weight or the volume. So first of all, upthrust. So here we can use this formula that upthrust is equal to loss of weight. So loss of weight is nothing but it is weight in air minus weight in water or the liquid. Okay. So weight in air is 450 gram force minus weight in air is 310 gram force. We can say upthrust will be equal to 140 gram force. This is the upthrust. Okay. So here this upthrust is equal to loss in weight of the body. Okay. So this upthrust and loss in weight both are equal. So our second and third parts answer will be same. Okay. Upthrust is equal to loss of weight. Okay. And which is equal to weight in air minus weight in water, which is equal to 140 gram force. Now we need to find out volume of the body. So we also have the another formula for upthrust. So the another formula for upthrust is this we are solving for the first part. Okay. Here we have solved the second and third part. Okay. Second and third part we had solved here. So for upthrust we have another formula. It is the volume of the body inside water or inside liquid multiplied with density of water or density of liquid into G. So upthrust we have 140 gram force. So 140 into G is equal to volume inside water. So volume inside water is equal to volume of the body because it is completely immersed. So that volume of the body is not known, that we need to find out. Multiplied with density of water. So here you can see the weight and apparent weight all are given in gram force. It means they had mentioned mass in gram, which is CGS unit. So for density, we will use density of water as it's in CGS unit. So density of water is 1 gram per centimeter cube. So we will take the value 1 into G. So this G and G will get cancelled. So we can say volume of the body is equal to 140 centimeter cube. This will be the final answer. Now, another part of the question is asking that state the assumptions made in part 1. So we only made one assumption in part 1, that we had taken density of water as 1 gram per centimeter cube. So we will write that assumption made in part 1 is density of water is 1 gram per centimeter cube. Okay, that's all. Okay, this is a bit tricky question. They had changed the sequence, so we need to solve for the upthrust first. This upthrust will be equal to loss in weight of the body, that is the difference of actual weight and apparent weight. And after getting these two answers, volume of the body we can find out with the help of Upthrust formula, that Upthrust is equal to volume of the body inside water multiplied with density of water into G. And since body is completely immersed, so volume inside water is equal to volume of the body. Okay. So you need to practice this question 2-3 times. Okay, that's all.